So we are looking at conic sections, these 5 sections, and arithmetic and geometric sequences. So we're going to look at that. So now let's look at these 4. And the last one is just a combination of these 4. So these 4 sections, and the last one here is a combination. It's just shifted conic sections. Okay? So let's start with the first one, which is in section 1.8, circles. Is a circle a function? No, it's 2 functions actually. Okay, before we do that, I just would like you to remind me, what is the distance between 2 points? What is the formula for the distance between 2 points? Assuming we have a point here and we have a point here, this is A and this is B. I'm calling this point x1, comma, the coordinates x1, comma, y1, and this one x2, comma, y2.
y2 minus y1.
Yes, x2, you're right. Let's start with that, but you're right. And then plus, because we formed the right triangle, right?
It's Pythagorean theorem.
Yes, y2 minus y1, everything squared. Agreed? Okay, I'm going to use this formula to determine the equation of the circle. So bear with me and say that this is a circle. I know it's not perfect. This is the center. It is denoted by, the x coordinate is denoted by h, and the y coordinate is denoted by k, h comma k. And what is this? The radius. That's okay. And let's say that this point has coordinates x comma y. Any point on the circle, anywhere you want to present it. Now my question is, what is the distance between these 2 points? It's, in this case, it's exactly, what is the distance between exactly r, correct? So I'm going to replace this by r. Good. Then I have the square root of, I'm following through with the same formula. X minus, very good, squared plus, excellent, very good. This is perfect. However, we normally like it without the square root. If I want a formula like this one without a square root, what should I do to both sides? Exactly. So I square this and I square this, and I get x minus h squared plus y minus k squared equals r squared. This is the equation of the circle. The equation of a circle with a center h comma k and the radius r. So let's look at a few examples. On page that's why section 1.8 is together with the rest of chapter 11, because we consider that it should have been there. Very good. On page, I'll find it today, page 94, we're going to look at problems 87 through 110 on page 94. Okay. Find the center and radius of the circle and sketch its graph. So let's say I want x squared. That's problem 90. You can choose the next one. Plus y minus 2 squared equals 4. So can anyone identify the center? and the radius. And once you have that, then we will graph it. What is the center? The radius is 2. Excellent. Now together, let's compare this to this. So how much is it's h, which is the x-coordinate of the center? 0. Now let's compare this to this. How much is k? So here's how we graph it. We plot the center first. 0 for x, 2 for y, right here. I will create 4 points, east, west, south, and north of this point. How many units away?
2.
2. So here's one, here's the other, here's the next, and here's the next. I created 4 points, 2 units away from the center. This is the equation that is not a function. This has the equation this. So all points on the circle, verify this equation. Any point, you name it. So for example, if I want to check, for example, this point is 0, 0. When I plug 0, 0 into this equation, I have to get 4. Otherwise, the point 0, 0 is not on the circle. 0 minus 2 is negative 2. Negative 2 squared is 4. 0 plus 4 is 4. Any point on the circle must verify the equation of the circle. Is that clear? Okay, very good. 92. In 92, we don't have to graph it. I just want you to identify the radius and the center. What is the radius of this circle? Good. What is the center of this circle? Be very careful. Always remember transformations. What does x plus 1 do? Exactly. Yes, comma. Exactly. So that's the idea. That's the idea. Very good. Now I want to make, I'm just making this up. I would like you to identify whether this is a circle or not. Okay, so if it's a circle, what will be the radius and the center? If I cannot find the center and the radius, then it's not a circle.
So the radius would be 1 and the 0, 0.
It is a circle centered the origin with a radius of 1. Very good. Okay, give me 96. Give me an equation of a circle with centered at negative 1, 5 that passes through negative 4, comma, negative 6. Let's picture this. First of all, what am I not given? Right. So if the center is at negative 1, comma, 5, and I plot this point, this must be for the radius. All I have to do is find the radius and I'm done. So please tell me, how do I find the radius, which is basically the distance between these 2 points? Let's write the formula one more time so we don't forget. I recommend writing underneath before you plug them in. So my x2 is negative 4. My x1 is -1. My y2 is -6. My y1 is 5. It's a distance formula because I have to determine the radius. This is the distance, but it's actually the radius, not the diameter. Sorry, I used D and I confused you. I apologize. Okay, how much is -4 minus -1? -3 squared, 9. Plus -6 minus 5, -11. -11 squared. So this is 130. The radius is the square root of 130. Now I'm ready. I have the center and I have the radius. Anyone would like to dictate the equation of the circle that is centered at -1, 5 and definitely passes through the point -4, -6? Yes. Careful. Yes. Yes. Plus. Yes. Excellent. Because you squared R and you got 130. Is this okay? Okay, last type on same page, please choose from 103 to 108. Of course, these are the most difficult ones, and you will tell me what needs to be done in a minute. And then I would like to sketch 109 or 110. It's up to you. Are we picking from 103 through 108? Okay, then I will. 106. X squared plus y squared plus 1/2 x plus 2y plus 1 over 16 equals 0. The question is asking us, is this a circle? And the answer is, I have no clue. But the partial answer is this. If there is a way of presenting all this, well, I should say all this, in this way, then yes. So if I can manipulate this equation and make it look like this, and this is a positive number, not -5, because I can't take the square root from -5, right? So if I get something like this and a positive number here, then yes, I will say this equation represents a circle. But if there is no way of changing this into this, then I'll say, sorry, it's not a circle. If, for example, if I have minus here and plus here, if I have a negative number, I'll say, no, it's not a circle. Which method we have to think of to change this into this?
I feel like they just squared it out.
The method is called yes, but it has a name. It's somewhat factoring. Yes, I agree. See, everything reduces to simplifying factor. Almost everything. So, question is, how is it called? The process of changing something like this into something like this. Completing the square. Yes, it comes back to haunt us. Okay, so this and this, the middle coefficient is 1/2. I divide it by 2. When I divide 50 cents by 2, I get a quarter, 1/4, and I square 1/4. So let me write the procedure one more time. So it's completing the square. Step 1, I identify the middle coefficient. Step 2, I divide the middle coefficient by 2, and I get 1/4. And in step 3, I square 1/4 to get 1/16. But look at this. Awesome. It's already there. I didn't need to add it. But the fourth step will be add 1 over 16 to both sides. Not to one side only, but to both sides. And I'm happy because it's already there. So then these three terms, this one and this one and this one, will be in here. In where? In where?
Okay, now what was that again? I get it right.
We have an agreement for 3 months and a half.
X plus 1/4.
Exactly. Thank you. X plus what we squared to get 1 over 16. Excellent. Okay. Now we repeat the procedure for y. Middle coefficient. 2 divided by 2. Square. 1. So I have to add 1 to both sides. Now this and this and this will form another perfect square, and the only thing that is left on the right hand side is 1. Can anyone give us the perfect square for y this time? Exactly, y plus 1 squared, we have an agreement, the first term squared plus 2 times the first times the second plus the second term squared. Okay.
So that's equal 1.
I'm not allowed to add to one side without adding to the other.
Yeah. So where did 1/16 go then?
This and this and this are all in here. It was given to us. I didn't have to add it.
Yeah, but when you added both sides.
I didn't. It was already in the problem. For the x, I didn't have to add to both sides because 1 over 16th was already there. So I grouped it together with these two. But for this one, for these two terms, I did not have the third one, so I had to add it.
So you just added it. So you just look at these as like two separate quadratic equations.
Not really, just two different parts. One part that has only x in it, and one part that has only y in it. And I have to complete two different squares, one for x and one for y. If that's what you meant, yes.
Yeah, that's what I meant.
Yes, yes,
I got you.
yes. So in order to complete the square for y, because see, the equation of the circle does not have x and y in the same expression, squared expression, right? Here it has only x and a number. Here it has only y and another number. And, well, these numbers can be the same. You know, doesn't matter. But x is only here and y is only here. So I can't have something that has x and y and square. So that's why I have to, it's a very good question actually. I never thought of explaining that. Thank you. Okay, so y squared plus 2y needs a 1. And if I add a 1 here, I have to add it here. Is that okay now, everyone?
Yeah.
Yes.
One more real quick.
Yes.
So say the 1/16 wasn't there.
I would have added 1/16 to both sides.
Okay.
And I would have added on this side 1 plus 1 over 16.
Okay, cool.
Oh, absolutely. If I did not have that, or if I had anything else, but let's say if I had here 5, I could have not grouped it with this and this. 5 would have gone to the other side, and I would have added 1 over 16 to both sides. But it happened that what I needed was already there.
So if 5 would have been there, you just subtracted 5.
Put it to the other side.
Okay, cool.
Yes, and add it up with whatever I have in there.
Okay.
Add the 1 to both sides.
Yes, and 1 over 16, then the -5 and the 1.
Okay.
Yeah.
Let's do another one.
Oh yes, of course, we didn't finish.
Okay.
No, because we need to identify the center, and we need to identify the radius. So now can we say that this is the equation of a circle?
Yes.
Yes, because we complete the square with x in x, we complete the square in y, And the other side, so first of all, remember, these are mandatory characteristics. Something with x squared, with a number or not, plus, mandatory plus, not minus, mandatory plus, and here only y with a number or not, and a positive number on the other side, because otherwise we can't take the square root from it. So the center, one more time, is comma, and the radius is, that's it. Okay, please choose now. Anything from 103 to 108. 109, I'm sorry. No, 108. And 9 and 10 will choose a problem. So which one?
We do 8. I mean 108.
Yes. So we have 3. So this is 108. 3x squared plus 3y squared plus 6x minus y equals 0. Very good. So the same question. Is this the equation of a circle? The answer is I have no clue. It depends on whether I can present it as x minus a number squared plus y minus a number squared equals a positive number. Good. Now, what do I know about completing the square? There is one mandatory condition before I even touch it. The leading coefficient must be 1. The leading coefficient for x squared, the leading coefficient for y squared must be 1. I have no choice. So this is x squared plus y squared plus 2x minus 1/3 y equals 0. And now I have to group. And what do I add for x squared into x?
So you got 2 by 2.
Yes? I get 1 and I square 1.
And then you add 1.
Very good. So then what is the perfect square for x?
X plus 1.
Good. So this is accounted for. This is accounted for. This is accounted for. All those 3 are in x plus 1 squared. That's the agreement we have, right? Good. Now let's look at y. What does y need? So the middle coefficient is negative 1/3. Exactly.
Squared.
Yes. 1 over?
36.
Exactly. Very good. So now this and this and this are accounted for here. Yes? It cannot be plus because the middle coefficient is negative. Exactly. And now I have to add those two numbers on the right hand side, which I get 37 over 36. Now I'm asking myself and I'm asking you, is this the equation of a circle? Yes. Good. So then the center is, and the radius is, comma, good. And the radius, I have to take the square root from 37. I'm just going to write it like this. It has to be exact. And I have to take the square root of 36, and I get 6. Now, for some reason, I cannot show you with the software, but I want to show you with this calculator. Go to apps. You may not have all this. My old calculator doesn't have it. Let me know if you see this. When you press on apps, right here. Apps. And I think it's better if you scroll up. If it works. No, it doesn't. Okay. It may work or not. Okay. And go to Conics. Okay. I messed up. It's better to go down because it's C. Okay. So go to Conics right here. Do you have Conics?
Yeah.
Okay, press on Conics. Enter. See, you have all the 4 conics that we are going to look at. Circle, ellipse, hyperbola, and parabola. Let's click on circle. So here's our circle. We already have it in this form. So we already have it in this form, but you may have it in this form as well. So let's look at one that was nice. Let's say I click on this form, click on enter, press enter, and it will ask you, what do you want the coordinates of the center to be?
Think about the first one.
The first one, because it has completely square.
It kind of just gives us the formula.
Yes, it gives you the formula as well.
Nice.
Very good. So let's say let's say 2. Let's say k negative 3. And let's say the radius of 4. And press enter. Why? Press on graph, I'm sorry. Press on graph, I'm sorry. And you got the circle. Everyone? Got the circle? Excellent. See? For some reason, I'm not sure why, this one doesn't have it. I tried it right before you came. It doesn't, in app for math, I pressed and that gives me all this and I don't know what else to do with it. I have no idea what this is.
So we can also check, because it gives you that ax squared plus ay squared plus bx plus cy. So we can just plug in. I know
Yes.
that's cheating, but
For the second option?
yeah.
Yes.
You just plug it in and check
Yes.
the circle.
I don't know. I don't think it will give you. Let's go back. Let's try. I don't know that it will give you the center. It will complete the square for you. So if you go to the circle and this time you go to the second one and you plug in what we just had, right? A is 3. B is 3, right? C is 6. Y is -1. And if you press on graph, it will graph it for you, but it will not tell you what is the radius and what is the center.
Yeah. But at least we know, like, going up front, if it's going to be a circle or not.
You could.
Yeah.
You could. Very good. Any questions on this? Let's look at one more, 109, 110, and let's move on from the circle. Move away. 109, 109, 110. Which one? Let's do 110. We are given ordered pairs. I'll explain the notation in a second. X squared plus y squared greater than 4. The question here is catch the region given that by this set. So let me translate this to you, what it means. This is a set of ordered pairs. How do I know? Right here. A set of ordered pairs x comma y. This bar, we read that as such as, or with the property. So the set is made of ordered pairs having the property that this is fulfilled. Every ordered pair has to fulfill this condition. So it's a set of ordered pairs satisfying or such as or having the property this. Okay, so I have to graph this. Give me the equation. I'm not changing the inequality into an equation, but just give me the equation as if it would be an equation.
X squared plus y squared.
How do I graph this? What is it? Circle, radius, center. Exactly, very good. So let's graph it. So it's centered at the origin with a radius of 2. 2 away, 2 away, 2 away, 2 away. Do not graph the circle just yet. Does the inequality have the equal symbol? No. I cannot graph it as a solid curve. So I have to graph it like this.
Why are you like
Because there is no equal symbol.
Oh,
So this is the equation x squared plus y squared equals 4. I can see that the entire region, the entire plane, is divided into two regions. The region inside the circle and the region outside the circle. I'm going to use the origin to check the inequality. If I put the origin in here, 0, 0, I get that 0 is greater than 4. So I'm checking the inside region. 0, 0. Is 0 greater than 4? False. Therefore, any point in here will not verify the inequality. So where is the region? Exactly. Everything I see in blue verifies this inequality. All ordered pairs that are in the blue region will verify this inequality. No point inside the circle will verify that inequality. That's it. You have to graph it. You can't do anything else. This is the solution. You have to graph it. There is no other way. Any questions here? Back to chapter 11 now. Because we already talked about the circle, I would like to continue with the ellipse, hyperbola, and then come back to the parabola. And you can say parabola again. Exactly. However, we are going to talk a lot about this kind of parabola. Is this a function? No, it is a parabola, however. It's called a conic section. Okay, so let's continue with 11.2. The ellipse. On page 733, in case you don't have your book, I would like to show this. And what is the definition of an ellipse? Yes, if you want to say that. What was it? Let's go back for a second to the definition of the circle. The circle consists of set of points that are all found at the same distance away from the center. That's the circle. So the circle is made of all sets of all ordered pairs that are found exactly at the same distance away from the center of the circle. So what will be an ellipse? An ellipse is the set of all points that are in the plane. The sum, so all these points on this ellipse have the sum of this distance plus this distance always the same. So this point, this plus this, will equal to the distance this plus this from this point. Will equal the distance of this plus this from this point. These 2 points are called foci. So let me graph this for foci. Focus, singular, foci, plural. Foci. So here is an ellipse. Here's an ellipse. Let's say it has the major axis starting at -3 and 3, so the length is 6. And let's say, and it's centered at the origin. And let's say the minor axis starts at -2 and ends at 2. So major axis, 6, between -3 and 3 if you want. And minor axis 4 between -2 and 2. And here comes the ellipse. Centered at the origin. With the major axis on the x-axis, because it can be the other way around. It can have the major axis on the y-axis. I don't know why we have to calculate. I don't know exactly where the foci are, but let's say this is F1 and let's say this is F2. This point, any point on the ellipse, would have the same characteristic. Like any point on the circle had the same characteristic. The distance between itself and the center was always the same, right? In this case, this distance plus this distance, the sum will definitely be the same if I have a point here. This distance plus this distance. If I have a point anywhere, if I have this point right here, this distance plus this distance will be the same. This is the characteristic of an ellipse.
So the foci are the 2 points that are equal all
Whose distance from any point, whose sum of the distances from to any point on the ellipse will always be constant.
Okay.
So this plus this will always equal red plus red, will always equal green plus green. For any point. One more time, this circle, same distance from the center. Here, the same sum of distances from the foci to it. Okay, so let's look at on page 734 at the bottom. So this is the first ellipse that we just graphed, page 734 at the bottom, in which we had these points, the major axis between -a, so you see major axis, horizontal, length 6 in my example. Vertical axis, in this case, it's the minor axis between what I showed you in my example, -2 to 2. And here is the equation. So the equation of the ellipse requires 1 on one side This is mandatory. In the circle, we could have any positive number. But in the ellipse, in order to identify the type of ellipse, we have to have 1 on one side, mandatory. So let me give you a couple of examples, and then we'll come back and finish up that part. Okay. Let's say I have 9x squared plus 4y squared equals 36. I'm looking at problem 11 on page 739. What I would like to determine first is if this is an ellipse, and if it's not an ellipse, what is it? And then I would like to graph it, and then we'll look at more details. So with the circle, if you remember, we had to complete the square to identify the center and the radius. Here, this is my starting point, which means I have to do what? Excellent. So then I have 9x squared over 36 plus 4y squared over 36 equals 1. That must be the first step. Okay. Yes, it's a must. Very good. So now I will simplify. What do I simplify by in the first equation? Yes, and I get 4 in the denominator. What do I simplify by in the second equation? Very good, and I get 9 in the denominator, and that's 1. Very good. Now, I will identify what? So clearly, this tells me what? That a squared equals, by the way, I should have asked this. Is this an ellipse for sure? I have plus, I have two ratios, and I have one on the other side. So this must be an ellipse. A squared equals 4, and how much is b squared? 9, which means that a, on the x-axis, the ellipse will go between what and what?
-2, 2.
Correct. So I will say a equals 2, and I will write -2 into in a minute. And on the y-axis, the ellipse goes from -3 to 3. So then b equals 3. That's all we need. And centered at the origin. What if I have, here's a question for you. In parentheses, we're not going to do this now because this is the last section of this chapter. What if I have this? What will be the center of this ellipse? That's it. But here, obviously, this ellipse is centered where? At the origin, with on the x-axis -2 to 2, on the y-axis -3 to 3. That's it. We'll get to more details in a minute. I just wanted to graph a couple before we do anything else. Ready? It's not easy to graph an ellipse by hand. So that's the ellipse. Any questions? Now, if we are asked to find the vertices, what will you say? You will say 2, 0 is one vertex. You will say -2, 0 is the other vertex. You will say 0, 3 is one. And you will say 0, -3 is the other. Acceptable? Let's identify now the foci. Okay. In order to identify the foci, let's take a look. F1, we need to find this constant, which is c. C squared is a squared minus b squared. Yes. Here, on the other side, on the when the ellipse has a major axis on the y-axis, then it's always the longest minus the smallest, because remember, this is a difference. The difference has to be positive, otherwise I won't be able to find the square root. So I don't like the way they present it here, and they twist it around, and they say that this is A now and this is B now. There is no need for that. Okay? So remember that C has to be determined as the largest of the two minus the smallest of the two. So then C squared in this case will be 9 minus 4. I cannot write 4 minus 9. So this will be it will be 5. So now the foci, they have to be on the y-axis. So C will be the square root. So C squared equals 5. I take the square root. C equals plus or minus the square root of 5. And the foci must be on the y-axis. Always on the major axis. Always. So F1 will be at 0, comma, the square root of -5. And F2 will be at 0, comma, the square root of 5. So the square root of 5 is 2 point blah, blah, blah. So I'm going to put it here, and I'm going to put the other one here. So this is F1, and this is F2.
So you say the major...
The major axis is always the longest.
Oh, okay.
And the foci have to be on the longest axis. Okay, so let's look at another. Let's say problem 12. So in problem 12, we want to graph the ellipse, and we want to find the foci for now. And of course, the major axis, the minor axis. And I will also explain the last item, which is the eccentricity. How far away is it from a circle? Okay, so 12 is 4x squared plus 25y squared equals 100. Oh, let's graph the ellipse with a calculator before we move on. So go to apps. Again, go to Conics. Choose the ellipse as the second item. Press enter. And now it's asking us to know whether it's the first option, which means the major axis is on the x-axis, or the second option where the major axis is on the y-axis. Which one will you choose? We choose the second one. Press enter. Very good. Now, there is nothing to subtract, right? We know that the ellipse is centered at the origin. So there is no A, put 0. There is no B, put 0. No, that's not what I meant. I'm sorry. Our B is 3. Our A is 3. Our B is 2. But H and K are 0. Agreed? Right? So under Y, I have 9. So that will be 3. Under X, I have 4. So that will be 2. But it's not shifted. It's not a shifted conic. It has the center at the origin. So now I'm ready to graph. And press graph. And here it is. And that's the ellipse. Major axis 6. And it's on the y-axis. Any questions? Okay, so now with 4x squared plus 25y squared, we want to find A and B. We want to graph it. We don't know what it is, where it is, and so on and so forth. So what do? I have to divide by 100. That's my first step. So 4x squared over 100 plus 25y squared over 100 equals 1. What if I had here negative 100? What would you have said? Not an ellipse. Not an ellipse, for sure. All terms in the ellipse have to have positive. Okay, so now what do I do? So I have x squared over 25 plus y squared over 4 equals 1. So where is the major axis? On the x-axis. Because this number is bigger, right? So I will have A, which is 5, and I will have B, which is 2. So when I graph it, the vertices are only on the major axis. That's when we are asked the vertices, so it's going to be just the major axis. So 1, 2, 3, 4, 5, that's 1 point. 1, 2, 3, 4, 5, that's the other. So this is negative 5 and 5. And then positive 2 and negative 2. So that's the ellipse.
You always find the square root of what's under x and y.
Say it again.
You always find the square root of what's under x and y.
Yes. That would be the A and the negative A. Yes.
So A would be X and B would be Y.
Yes.
Yes.
So this comes from here and this comes from here. So now I have to determine c squared, which is, in this case, 25 minus 4. So c squared equals 21. So when I take the square root, I get this. And since F1 and F2 will be on the x-axis, can anyone give us the coordinates of F1 and F2? Square root of 21, comma, yes, and negative the square root of 21, comma, 0. So this is F2. I'm sorry, I should have started with right there. Okay, the last thing that we are asked to determine in all these problems is the eccentricity, E. E is a number between 0 and 1. So let's take a look. I like this graph in your book. Ready? The eccentricity is a measure of how stretched, quote unquote, the ellipse is. If the eccentricity is close to 0, it's almost a circle. If the eccentricity is close to 1, it's more elongated than, as E increases, the elongation, or it's the stretch, that's what they say, and I like that. The ellipse is more stretched. If the eccentricity is close to 0, it's a circle, or almost a circle, I should say. Okay, so let's determine it in this case. So C, in our case, C, I will take only the positive, is the square root of 21 divided by A. A in our case is 5. So let's determine this. The square root of 21, I use the calculator, and I divide by 5. So E is 0.9165, which says that the ellipse is far away from a circle. Is that true? What about this one? Do you think that this one will have a higher or a lower eccentricity than this one? Lower. Okay, let's calculate it for this. So the eccentricity for that one will be the square root of 5 divided by the major number, which is 3. Always by the longest, divided by the longest. So the square root of 5 and divide by 3, I got E equals 0.7453. Is this expected? Yes, we expected to get a lower eccentricity. Higher the eccentricity, the further away from the circle. Okay, so we need more examples from ellipse. Then we are going to look at the hyperbola and that parabola mainly. And the last section here deals with shifted conics. In other words, as I mentioned, we will have something like this. If you want, yes. I know I have 6:46 almost. Sorry about that.